Greetings, everyone. I've had some people ask some questions about exponents. So I am going to do a couple examples and talk about the rules as I go through it. Okay? So I'm going to do actually exercise 3.6 on page 105 as an example. And then I will do one from the homework as well. Now, what they want us to do here is to simplify using our power rules. And remember that our power rules are, if the base is the same, then we just add the exponents. That's one of them. Okay, if we multiply, so if I have the base to a power and raise that whole thing to a power, then I multiply the exponents. I could also have the powers the same and, the base is the same. Let me erase that. The bases are the same, but the exponents are different. I already have that. Sorry. I'm going to have the powers the same, but the base is different. Well, then that's okay. If the powers are the same, that's the same as multiplying the bases to the m, but I can't do that if everything is different. Okay, some things have to be the same. Those powers need to be the same. Okay, or I can do division. So I have a to the m divided by a to the n. If our bases are the same, then I can just subtract. Okay, so if the bases are the same and the exponents are different, I can add. If the exponents are the same and the bases are different, I multiply and take it to the same power. Okay, so those are our rules. So now what they want us to do is to take this number, 6 to the 4th, 12 cubed, 15 squared, divided by 9 squared, 8 squared, 5, and simplify that as much as possible. Okay, and we want to leave it in prime factorization. So what I'm going to do is I'm going to think about each number differently. Like 6 is 2 times 3. Okay? Well, I can take 6 to the 4th and rewrite it as 2 times 3 to the 4th. 12, I'm going to go ahead and write that as 2 squared times 3. And I'm going to take that to the third power. 12 is 4 times 3, so you can see that I have that there. 15 is 3 times 5, and I'm going to take that to the second power. Now, 9 is 3 squared to the second power. Okay, this 3 squared takes care of 9, and the squared on the outside of the parentheses is the squared that is my exponent. 8 is 2 cubed to the second power, and 5 is just 5. Okay? All right, so now what I'm going to do is I'm going to take each number and write it independently. So I have 2 to the 4th, 3 to the 4th, 2. Now notice here that if I have squared, 2 squared to the third power, that is the same as 2 to the 6th power, 3 to the third, then I have 3 squared, 5 squared. On the denominator, I have 3 to the 4th and 2 to the 6th. And then a 5 hanging out here by itself. Now, for me, I look at this and I see that there is a 2 to the 6th and a 2 to the 6th. So I know those are going to divide out right away. And here's a 3 to the 4th and a 3 to the 4th. Those are going to divide out. Okay? Because 3 to the 4th divided by 3 to the 4th is just 1. So I would go ahead and do that because it will simplify your life easier later. Now, if I have 2 to the 4th, I don't have any other 2's, any other numbers with a base of 2. So I'm just going to leave 2 to the 4th there. Now, if I look at this, I have 3 cubed and 3 squared. Well, one of our rules said that if the base is the same, we can add the exponents. So that's 3 to the 5th. This is 5 squared over 5. Okay, now another one of our rules says that if I have the base is the same, so I'm just looking at these, the base is the same and I'm dividing, I can subtract the exponents. So 5 squared So off to the side here, I'm going to write 5 squared divided by 5. Well, even if we think about it just like if we went out and did it, that would be 25 divided by 5, which is 5 to the first. So I've got a 5 hanging out there, and that's my answer. Okay, so doing a problem like this practices all of the rules of exponents.